Hi, welcome to Dissolve Chemistry. So in the previous video of thermodynamics, we have discussed regarding thermochemical equation conditions what we have to take. So let us continue our discussion on thermodynamics. In this particular video, we will discuss regarding Hess's law of constant heat summation. Well, prior to going in detail with this, let us recap the things what is required for this. We know that the term enthalpy, it is a state function. What do you mean by state function? The entity of whose value only depends upon the initial and the final state. So regarding this state function and path function, we have made a video. So please, to get more details, you watch that particular video and you will understand that. Okay, what is the meaning of this is, so it only considers now what is the enthalpy, and after that change, whatever the way you bring in single step, you bring in multiple steps, okay, or in different way. So overall enthalpy of the reaction depends upon the initial and final state of the system. That's what it means. So this state function, okay, so it is being utilized to a law to calculate enthalpies of the reaction where it is difficult to determine directly by doing an experiment. And how we define this Hess's law? A enthalpy of the reaction is always remains constant. Either you bring it in a single step or in multiple step. So that enthalpy remains the constant, or it is not going to vary based on the way the change has been brought. Okay, so we'll take one example. Let us say carbon graphite, okay, solid. We want to convert this into carbon monoxide. Okay, so we will get carbon monoxide gas. And what is the enthalpy of reaction, right, of this carbon monoxide? Now, whenever you convert carbon graphite to carbon monoxide, the problem what we come across is that slight amount of carbon dioxide is also going to form. So therefore, whatever the enthalpy of reaction we make note here or we determine, that exactly will not correspond to the formation of the CO molecule. So therefore, then how to determine that? So let us see that step by step. So what you do is, you take carbon graphite, okay, you bring its complete combustion in presence of excess of oxygen, then it will convert into carbon dioxide gas. And total enthalpy of this reaction is 393.5 kilojoules per mole. Okay, so now what we have done, we have taken graphite and in sufficient amount of oxygen we want to give carbon dioxide, then the total enthalpy change of this reaction is corresponds to 393.5 kilojoules per mole. Now what you do is, you take now carbon monoxide. Instead of carbon, we will take carbon monoxide, and once again what we will do, we will react this with half mole of oxygen or excess of oxygen you take, but we are supposed to write the balanced equation, so I am writing half O2, but sufficient oxygen if you take, excess of oxygen will remain as it is. So then it will convert into carbon dioxide. So then the enthalpy change corresponds to, for this reaction, is minus 82.5 kilojoules per mole. Now, from these two equations, we are found of change in enthalpy of carbon monoxide that we can calculate by utilizing these two thermochemical equations. Okay, so how we can do that one? Make sure that your carbon monoxide is on the right side. So to get carbon monoxide on the right side, what I have to do? I have to change this equation, or I have to reverse it. When you reverse, already we have discussed in the previous video, whenever we reverse the thermochemical equation, the enthalpy, sign of the enthalpy is going to change. It is minus here. So therefore what? If I reverse this equation, so then the sign changes from minus to plus. Okay. So let us reverse it. Right, I will write here. Let us take CO2 on this side plus, not plus, directly put the arrow mark. Then to get CO gas plus half O2. What operation we are doing? We are reversing the equation to get the desired equation what I want. Okay, you have to change the things as per the requirement of your desired equation. So when I am reversing, the sign changes from minus to plus. 282.5 kilojoules per mole. Okay, so now what we will do? We will add this equation. You call this equation as 3. We get the desired equation. Okay, we will see that. And carefully you observe that what operations we are doing in calculating these equation, thermochemical equation. See what I did? I want carbon monoxide on the right hand side. So therefore what I did? Second equation I reversed. So when you reverse the thermochemical equation, whatever the enthalpy change is there, its sign is going to change what it has exactly. So now let us add these two equations. Carbon dioxide, which are right and left. So therefore we are cancelling it. So half O2 here, 1 O2 is there. So therefore half O2 will remain. 1 half O2 will go. So therefore we will get like this equation. Graphite, okay, solid, plus what is remaining here? Half O2 already cancelled. Another half O2 will remain. Okay, we will write like this: half O2 plus half O2. 1 half O2 will get cancelled and another half O2 is remaining. Okay, gas. So now we will get carbon monoxide gas. So therefore delta H is equal to, you just add up these two. So then you will be getting what? 111. Okay, kilojoules per, right, kilojoules per mole. What does it indicate? So therefore, as I could not get directly by doing the experiment of passing a controlled oxygen, okay, to form carbon monoxide, it is difficult. So therefore, to get its enthalpy of reaction, we can go by this way. And this is what is the main importance of this Hess's law. Okay, please make note of this. Then we will generalize this one. Okay, I hope you have understood this. Okay, let us consider a general equation reaction where I want to determine A is converted into D. Okay, so one is I can convert this A to D directly. Okay, or I can convert this A to D in several steps. Okay, we will see that one. So if I can convert this A to D in single step, so then we call it as enthalpy of reaction. Okay, now if I carry out the same thing in multiple steps, okay, so then what it turns out to be, I am suppose, for example, I am converting A to B, right? So therefore we call it as enthalpy of conversion from 1 we call, right? So then we will convert from B to C. C we are converting, then we call it as what? Delta enthalpy of reaction H2 we call. Then C to D we are going to convert. Okay. So then enthalpy of reaction as 3. Okay. So now either you convert from A to D, or A to B, B to C, C to D. So then the change in enthalpy is constant. So therefore this enthalpy of reaction H is equal to sum of all these enthalpies. RH1 plus delta RH2 plus delta RH3. Okay. So this you should remember because it is very important in calculation of lattice enthalpy using Born-Haber cycle that we will discuss in upcoming videos. Okay. I hope you have understood what do you mean by Hess's law and what it implies, and its application we will see in the Born-Haber cycle. Right? So next is we will go to a different enthalpies. Well, now we will discuss different other types of enthalpies. Okay, so first we will take enthalpy of combustion. Right. So what do you mean by enthalpy of combustion? See here, anything if you burn, okay, so we will get energy in the form of heat. Any substance you can take. So therefore that we call it as what? Combustion, burning any substance, okay, in open air, excess of air, and whatever the energy is released. Always remember these combustion reactions are exothermic reactions, okay, means always heat is evolved, right? Energy is evolved in the form of heat. So therefore, the enthalpy of combustion, how we define the amount of energy released when 1 mole of substance burnt completely, okay, or combusted completely, we can say, burnt completely at constant temperature and pressure where the reactant, where the substance and its combusted product were in reference or standard state. Okay, so therefore we call it as, it is nothing but your standard enthalpy of combustion we define, okay, in standard state. Right? So means 1 mole of compound if you completely burn. We will take example. In the previous video in defining thermochemical equation, we have taken ethanol, C2H5OH, okay, upon complete combustion in presence of air upon burning, we will get carbon dioxide gas plus H2O liquid. You should remember this. H2O liquid is in reference state. Liquid means reference state. CO2, of course, its reference state or standard state is gaseous state. So therefore, we have mentioned like that only. Here we will take gas and this is liquid. Okay. Then our enthalpy of reaction or combustion will be what? Cv is equal to minus 1367 kilojoules per mole. Okay, so this is what is enthalpy of combustion. The things what we have to make note is that we have to take the substance in standard state, okay, and we are burning oxygen. Of course, it is gaseous state is the standard state or reference state, and your product should be in standard state. Why I am saying, particularly I am mentioning, you should remember that whenever we do the reaction, the combustion reaction. If it contains hydrogen, it will convert into water. So initially it will be in the gaseous state, means it is still having energy. Okay. So therefore what we have to consider? We have to consider H2O liquid, means we should allow this to leave the energy, and that also be included into the your enthalpy of a combustion. Okay. So because of that reason, we have to mention the states of the reactants as well as the products. Okay, I hope you have understood what is enthalpy of combustion. We will do problem separate video I'm going to do on that. So we'll solve problems on Hess's law, this enthalpy of combustion, determination of lattice enthalpy and all that. Okay, now let us talk about enthalpy of solution. Okay. So now what do you mean by solution? Solution means addition of two or more components or mixing of the two or more components. Means one will be solute, another will be solvent. And we mix, dissolve that compound. During that dissolution, what happens? There is an energy either being absorbed or released. Okay, that depends. We will see that one. What do you mean by that? So only enthalpy of solution means when you add any substance to the another liquid, one used to be solute, another used to be solvent. When we mix together, then what change in the enthalpy is that we call it as enthalpy of solution. Okay, the change in enthalpy change in enthalpy when 1 mole of solute is completely dissolved in sufficient amount of solvent is called enthalpy of solution. Okay, and your solute and solvent all should be in a reference state. If they are, then we call it as that. And if you carry out at constant standard temperature and pressure, then we call it a standard enthalpy of solution. If not, we will call it as just enthalpy of a solution. Okay, so here many things we have to keep in mind. That first thing is during dissolution, what happens, particularly if you take ionic compounds during dissolving, so the crystal lattice is going to break. Okay, so that crystal lattice, how far it is going to break, that depends upon what? That depends upon the lattice enthalpy. So how much energy is being liberated during its formation. And after that breaking of the crystals, okay, first thing is breaking of the crystal will takes place. Okay, once the crystal breaks, the next thing will be what? Then it is going to hydrated, means it is being, or the after dissolving. So what we get? We will get the ions. Say for example, Na plus, Cl minus, you are dissolving salt. Most of the salts all are ionic in nature. So if you dissolve, first what happens? Crystal will break. Then later what happens? Your ions will get segregated. So as the ions will get segregated, further followed by that what happens? They are being surrounded by the water molecule. We call it as what? Hydration. Okay, hydration of the ion will takes place. And here during that hydration there will be a change in energy. Two things are there. One is breaking of the crystal lattice requires energy because we are supposed to break that, and that is done by the solvent. Molecules are going to do that job. And therefore, if you heat, particularly ionic compounds, if you consider, the dissolution of the ionic compound is increases when you raise the temperature, because initially we need to break energy to break the crystal lattice in the solution. Then next what happens? So when these ions, after the breaking of the crystals, the ions are being surrounded by, particularly if you are mixing that in water. So water molecules are going to surround that or get hydrated. Ions will get hydrated. Once they get hydrated, then what happens? So there is a liberation of energy. So now, what would be the enthalpy of solution depends upon the two things. One is lattice enthalpy, and another one we call it as what? Hydration enthalpy we call. Amount of energy absorbed or liberated when a 1 mole of substance is dissolved or individual ions to give, and that is being surrounded by the water molecule or solvent molecules. So that we call it as what? Enthalpy of hydration. If the lattice enthalpy is too high, okay, lattice enthalpy compared to hydration enthalpy, if it is too high, okay, hydration enthalpy, then such crystals will not be soluble in a particular solvent, particularly you can take your water, okay. So lattice enthalpy, if it is low in compared to your hydration enthalpy, so then those crystals are readily soluble in water, okay. So you make note of these things regarding enthalpy of solution, okay. So next we will talk about enthalpy of atomization. Well, what do you mean by atomization? See here, any substance if you take, it will be an aggregate of number of atoms, isn't it? So they are held together by intermolecular forces, probably maybe hydrogen bond, van der Waals forces, or with the covalent or ionic bond. Now, atomization means we are freeing all these atoms from all these forces. So that is nothing but atomization we call, right? And to do that, of course, atomization always it should be an endothermic process, because we are breaking the forces, covalent forces, ionic forces, or you can take hydrogen bondings, all that we are going to do, leading to what? Individual atoms we are going to get, or our aim is to get the individual atoms of from that particular substance. That we call it as what? Whatever the change is there in enthalpy, whatever the amount of energy we are giving to do so, so that will be our enthalpy of atomization. Okay, we will define the change in enthalpy. Enthalpy when 1 mole of any compound is converted completely into individual atoms. Atoms is called enthalpy of atomization. Okay, enthalpy of atomization. We will take example. Say for example, so there is an hydrogen molecule. So now if you want to convert that into hydrogen atoms, we will get this. Okay. So whatever the change in enthalpy is equal to 435.0 kilojoules per mole. Means to convert dihydrogen molecule into hydrogen atoms, we need 435.0 kilojoules per mole. So this much amount of energy is required to get the individual atoms. In the case of, say for example, a crystal is there like sodium solid if you take. Now, if you want to get convert into sodium gas, whenever solid means all the atoms are compactly packed. Okay, so with metallic forces here we can say. Okay, so now you are breaking that because we want to make it atoms because we are defining atomization. So therefore, when you completely convert 1 mole of sodium into 1 mole of gaseous solid sodium into gaseous sodium, the amount of energy required will be our enthalpy of atomization. And what we are doing here, we are bringing from solid state to gaseous state. Okay, here what we are doing, gaseous state to gaseous state, here we are breaking covalent bond. Now here we are supposed to break the metallic bonds or metallic force what we have to convert that into gas. But here what is the change in the physical states, solid to gas, that also be referred as what? Sublimation enthalpy. Okay, it's the enthalpy of atomization, but in particular, in this case, we refer it as what? Sublimation enthalpy. Okay, so that corresponds to delta H is equal to 135 kilojoules per mole. Okay, so this is all about enthalpy of atomization. Okay, in the upcoming video, we will discuss bond enthalpy and lattice enthalpy, Born-Haber cycle. Okay, so dear students, I hope you have understood. So please don't forget to subscribe our channel to watch more videos of a chemistry subject, and we will keep on dissolving the different concepts of chemistry. Thank you for watching.